Okay. So we were discussing about router. Router is a layer 3 device. Packets forwarding based on IP address is routing table used as a forwarding table. And it is basically used to connect different networks like a LAN and a WAN, or two LANs or two WANs. And
Yes.
it's an edge device. This point is the most important point right now. Basically, we are going to configure router many times with many protocols and with many topologies. Okay.
Oh, okay.
So we are going to discuss router in detail because it is the layer 3 device which is very important. And as we discussed that layer 3 device is very important for network administrators or someone who is interested to learn about how network works. So
Yes.
all these things will come back and we will understand and we will make topologies in which we will use LAN versus WAN and multiple LANs and multiple WANs. It is going to happen. And we will see how routing table work and how it performs forwarding and how packets forward on IP address. We will see everything. But the most important point right now, I introduced router here because we were discussing LAN and LAN devices.
Yeah.
But suddenly I picked the router and start discussing here is this point. Routers doesn't forward broadcast.
Broadcast.
As you remember that in all our conversation, we saw the devices and the topologies which supports broadcast.
Yes.
We see that if our device receive a broadcast, it is going to forward that broadcast on other ports or to other devices.
Yes.
But router doesn't do this. Means if router receive a broadcast message on this port number 1, then it is not going to forward this broadcast to port number 2, 3, or 4.
Oh, like the bridge and the switch.
Exactly. Bridge and switch receive broadcast and forward it.
Forward is, yes.
But router doesn't forward broadcast.
Okay.
This
And
point is
sir,
very crucial.
one question, like we said that the broadcast from when we using bridges and switch, if one of the system is broadcasting, it is mandatory that all others will receive, or can we group it or not?
We can group that. We discussed about this broadcast domain, and I said that broadcast domain is not yet, and uh, we will create multiple broadcast domains within a network.
Okay. That is
Okay.
while we
Yeah.
configuring it.
Yeah, exactly. While we will configuring it, we will create multiple broadcast domains in a single network. And what is a domain? Logical grouping.
Logical grouping.
Okay,
Yes.
so that grouping we will create will be logical, not the physical. Physically, they are connected to a same network, but logically they will be separated. Okay, so we are going to do that. But
Yeah.
right now, the most important point is this one.
Yes.
Router doesn't forward broadcast.
Broadcast.
Okay, it
Okay.
is a universal rule. Every
Okay.
router has this property. Okay, and router, let me discuss something more about the router right now, and we are going to discuss again. Router is not a device which is dedicatedly built, or a hardware which is dedicatedly produced. Every device which works on layer 3 can become a router.
Oh.
Every device. And by this means my laptop or my mobile. Every device that has an IP address and has 2 or more interfaces or ports
Okay.
can become a router.
Router.
Means my laptop has a LAN network card and a wireless LAN network card, so it can become a router. Similarly, we use hotspot.
Yes.
So when we were using the hotspot, what we were doing, that we were connecting to two networks at the same time. One is the mobile network the data network, and one is the hotspot which we offer to some of our friends or someone we know, and they connect to us without through that hotspot. So what is happening behind that mobile device is working as a router.
Right. Connecting two networks.
Exactly, connecting two networks. And
Okay.
every layer 3 device can does this.
Okay, okay, sir.
Okay. So, and we
Okay.
are going to see this, that how this work. Right now,
Yeah.
the most important point is this one, that it doesn't forward broadcast.
Broadcast.
So here is a small topology, this one. And we have to find the total number of broadcast domains present here and the total number of collision domains present here. Now router is represented like this. This is the symbol of router. So whenever you are going to see a network topology diagram, this symbol is used for router.
Okay.
And this symbol is used for a switch.
Which
And this is a hub.
hub?
And this is a bridge.
Bridge.
Okay. So all four devices we discussed are present in this topology.
Okay.
Now we need to find how many broadcast domains are here and how many collision domains are here.
Okay.
So first of all, broadcast domains. Broadcast domain is easy. Can you tell me
Broadcast domains.
domains? Means if I send a broadcast, how far it can reach, which devices can receive that broadcast. That will be called as a domain, as a broadcast domain.
Okay. So here hub, switch, and bridges can broadcast messages. So those connected to that system will get that systems will get the broadcasted message. No?
And total numbers 1, 2, 3, 4, 5, 6. How many domains you see in this topology?
6.
6. Okay. I don't know how you say it 6. Let me clear one for you. For example, this PC generate a broadcast message. It will come to the hub. Hub supports broadcast. So it will going to forward this broadcast to switch. Switch also supports broadcast. So
Yes.
it will going to send the broadcast to this switch. This switch also support broadcast. So it is going to send this to this switch, and these systems are going to receive that. And also this router will going to receive the broadcast domain. Okay. So router will receive the broadcast, but
Yeah.
is it going to forward it?
No.
No. So what we can say or we can draw here that this whole place send to back. Okay. This whole place is a broadcast domain.
Oh, this is one domain.
Yeah, this is one domain because every device here can receive the same broadcast. So they are logically grouped as a broadcast domain.
Okay, sir.
Yes.
But we are grouping so that the if we group it like configure it so that the hub the switches doesn't receive the message that the leftmost system broadcasters, then it will
Yeah, these systems are also going to receive the broadcast.
unless we configure it. Otherwise,
No,
if we
no, 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 no. If we didn't configure anything and they are physically connected, they are going to receive the broadcast.
okay, if we configure it, then they won't be receiving it, no?
No, whether we configure or not. Sorry. If we configure these PCs in other domain, if we logically divide them, then they are not going to receive. But right now we say that they are in their default configuration. mode.
Default configuration.
Yeah, if they, because we haven't discussed any configuration yet, so everything is default right now. So by default, what is going to happen that each of these PCs are going to receive the broadcast generated by any devices. And by means any device, I include the router.
Okay.
Because router doesn't forward broadcast, but router has a capability to generate its own broadcast. Router can generate broadcast. So when it is going to generate broadcast, the broadcast is going to be sent to this switch and to this router as well.
Okay.
But when this router receive, it is not going to forward it.
Forward.
So router doesn't forward broadcast, but it can generate its own broadcast. Okay.
Okay, sir.
So this is the, so now we see that this is a domain,
Domain, yes.
a broadcast domain. And then now how many domains we have?
1 and 2.
1 and 2. And how about this one?
The 2 routers.
Exactly. When the router generate a broadcast, this router is going to receive. So they are logically in a group.
Yes.
Who can receive broadcast each other's broadcast. Okay. So there are 3 broadcast domains.
Sir, one in the
this
left
topology.
side.
Yeah, one in
the
the
right
left side. Exactly.
One
Let
in the
me create it here.
right.
The second one.
Yes.
Oh, send to back. Here comes the broadcast domain. What is happening? No way. I have to. So this is a broadcast domain. And third one is here. Between 2 routers.
And the left router broadcasts a message, the right one receives.
Yes.
But the switch
Doesn't forward. Because it is not going to forward it.
Sir, I have a little. It won't forward it to the switch, no?
Yeah, it is not going to forward to this switch. So this is our single broadcast domain, this is another, and this is another.
Sir,
There are 3 broadcast domains.
Sir, but router can forward between them.
No, router can't forward. Router never forward a broadcast. Router can generate its broadcast.
Okay. Generate. When the left router generate, then it is not
going to send the right router and bottom LAN network. Okay.
Okay.
Makes sense?
Yeah. Yes.
Well, and how about collision domains? This one is more complex.
Yes.
Because collision domains are not as simple as broadcast domains. Collision domains vary with functionality of each device, how devices work.
Yes.
So what are we going to do? For example, there is a hub. Let me send to back. So this is a collision domain, and this is, yeah, this one is collision domain.
Including the switch.
Including the switch port, which is connected to this hub, not the complete switch. Okay. So the broadcast domain and collision domains are not a whole device, but the uh, uh, but the uh, port connected, okay, interface connected is counted.
Okay.
So this switch is not counted in this collision domain.
Hmm.
Only the port of the switch, which is what is this? Which is connected with hub
Ah,
is counted as a
collision.
collision domain group. Is counted in the collision domain. The logical group
Okay.
is part of this collision domain. And why? Because when if this PC sends some data
Ah,
and at the same time switch send a data from this port,
ah.
that data is going to be collide
Collision. Yes.
because hub is a layer 1 device
Layer one device. Yeah.
and it performs as a bus topology. Inside there
Ah,
is a metal plate
ah.
which is connected, which directly connects all these interfaces with each other.
Yes.
So we can't do this that if this PC send the data, it is going to it's not going to collide with other because there is a half duplex
Ah.
mode. So it is a half duplex device. So that's why every port of this device is counted in a single collision domain.
Yeah. Okay.
Okay.
Yes.
Now where are other collision domains? From this
Ah.
switch to this switch.
Is that a collision domain?
Yeah, it can be. Oh, well, sorry, I forgot to clear one thing.
Ah.
Uh, we are going to suppose that in this topology,
Ah.
every connectivity is half duplex.
Ah. Okay.
Okay, we are supposing
Ah.
that every connectivity in this topology is half
Half
duplex.
duplex. Ah.
So if these two switches are connected through a half duplex mode, then
Ah.
there could be a collision.
Hmm.
But it is not going to happen that if this switch is going to send some data to this one and
Ah.
it is receiving data from this port,
Ah.
they are not going to collide
Ah.
because these two ports are not connected like in hub directly with each other from a metal plate.
Yeah.
There is a processor and memory
Processor.
inside which is
Ah.
going to process them one by one.
One by one. Yes.
Okay, so
Ah.
only there is a collision domain we can see. So let me write it
Ah.
here. This is a collision domain number 2 and I am using the red color for this
Okay.
and medium size. Okay, so this is collision number 2. This is
That is
1.
direct communication between the two switch.
Yeah,
Ah, okay.
a direct cable attached. And the
Ah,
cable
that
attached to the ports, these ports
ah,
are half duplex.
half duplex.
So
Okay.
when they are half duplex, so they are using shared medium, so data
Mm.
can be collided.
Ah,
Okay,
you
so
can.
this is the 2 and here comes the 3 and here comes 4 and here comes 5.
Mm.
Now, what total number will be there? The rest of the numbers, can you tell me? Count them.
The right side.
The right side. How many are there in the right side? Even the left side is not completed yet.
Um,
1, 2, 3, 4, 5, and there is this one
yeah, router.
because it is a half
Half
duplex
duplex.
communication. We suppose that
Yes.
everything in this topology is half duplex.
Half duplex.
So if this is half duplex, then there is going to be a collision.
Ah,
Okay,
yes.
so we can
Okay.
write that there is a,
Fixed.
sorry, I think that 6, no, I should use the copied thing. 6. Well, next,
The group with the bridge, that should be one collision
the
domain.
exactly, that's perfect. I think now you are making sense. The group here
Yeah.
with the bridge, it
Yes.
is going to be a single collision domain.
Yes.
Why? Because
Because
bridge is no, I'm sorry.
uh,
What should I say? It's not like that. Bridge is a layer 2 device, not a layer 1 device.
uh, but the connection is half duplex.
So exactly what it is, what if it is half duplex? But if because it is a layer 2 device, so
Layer.
if this PC is going to send the data,
Uh,
it is not
it is
going to collide
processed.
with this one.
Correct.
So
Yes.
every port is counted as a different collision domain
Oh.
because it is a layer 2 device.
Uh,
Only hub is the device which is layer
uh,
1 device. Its every port is counted as a single collision domain.
okay.
But in bridge and in switch, every port is counted as a different collision domain.
Okay.
Okay.
Okay, sir.
So now
So
we have
system
6,
uh,
7, 8, 9, 10, 11,
11,
12. This one is 13. And here
14.
complete 14 because this is a hub.
Hub, yes.
So because it is a hub, so every device is going to be a single collision domain.
Uh,
Hope you are getting this
yes.
somehow.
Somehow.
Basically, this is uh,
One
uh,
single.
a theoretical discussion, and if you are going to uh, give the CCNA exam,
Uh,
sometimes a question like this
uh,
comes up.
yes.
What am I doing?
Yeah, I can remember it, but the logic behind it, I'm somehow clear.
Hmm. What is happening? What is happening? What is happening? Logic behind this somehow clear.
Yeah.
If I give you some another question,
Yeah, I'll do.
you will do that. Okay, let me search after it is why it is not working.
All the devices connected with a layer 1 device, and that group would be a single collision domain, and
Yeah,
all the other lines are individual collision. Is that correct, sir?
I don't understand what you were trying to say.
If it is hub is layer 1 device. So
Exactly.
the devices around the hub and the hub, that one is a collision domain, single one.
A single one. Exactly.
All the others are different domain.
Exactly. Exactly.
I got
Well,
it.
let me see. CCNA. Broadcast domain college and domain. I hope it is going to break. Yeah, this one is simple.
Yes.
So what they are showing here, this topology,
Yes.
and there are MCQs that how many broadcast domains are here and how
Gentlemen.
many collision domains are here.
Yes.
So how many broadcast domains are here?
Broadcast domains. Uh, 1 and 2.
2. Exactly. There are only two broadcast
Two.
domains.
Since the only one router is that.
Exactly, because the router is here. So each port of router create a different broadcast domain.
Uh-huh.
Unless there is no router, then that will be counted as a single broadcast domain.
Yes.
So router is the only one which breaks the broadcast domains. Okay. So router breaks the
Okay.
broadcast domain.
Uh,
Now, how
uh,
many collision domains we have?
collision domains and the left side. Left side is every connection is a collision domain. 1, 2,
Exactly.
3, 4, 5, and 6. The hub is one collision domain.
Exactly.
So 6.
6. I don't think so that 6 is a option here.
Then
No.
5, 5.
5, 7, and 4. 5.
5.
1, 2, 3, 4. And this one is 5.
5, yes. I counted the router to hub.
The router to switch a different collision domain or this one.
That one, the router to hub is a collision domain, no, sir?
No, it is a it is a single collision domain
Single.
from router to this PC.
Okay.
Because if the router sends the data and this PC sends the data or this one, they are going to collide.
Collide.
So they are counted as a single collision domain.
Okay.
So hopefully now it is going to make sense.
Yes.
Let's move ahead. So how many collision domains we counted here?
14.
14. I'm not routing, not routing everyone here. Let's move forward. So if we were discussing the network devices,
Yeah.
so let's wrap it up so we can start configuring the devices.
Yes.
Now we have the hardware.
Yeah.
And in the hardware, we are targeting the memories in a network device.
Okay.
So we have 4 types of memories in a network device: a ROM, a RAM, an NVRAM, and a flash.
Yes. Okay.
So ROM is read-only memory, which is a non-volatile memory. Non-volatile means
Which
remember
the data is not erased when the
electricity.
electricity.
It is not electricity dependent.
Yeah.
So if there is no electricity, data is still going to be stored.
Yeah.
Okay. So what ROM does, it has a post behavior written in it.
Okay.
Post is power on self-test.
Just.
So every device has this post behavior. Every device, when it is powered on, it is going to self-test, and what it is going to test its hardware, that everything is working fine. Okay. Then there is RAM. RAM is volatile, and RAM has operating system and configuration files.
Okay.
Operating system is iOS. The Cisco's operating system is iOS Inter-Network Operating System.
Inter-network operating system.
Yeah, it is not that iOS which is Apple's operating system.
Okay.
Okay, that is a small I, and here Cisco has capital I.
Okay.
That's why Apple has to use a small I, because capital I was already with the Cisco.
Oh.
So it is Cisco's operating system and it is called iOS.
Yes.
So there is NVRAM. NVRAM is also non-volatile, and it stores configuration files. And there is flash, which is just like hard disk. Even right now in new devices, we don't have flash. Even we have NVMe and SSD for the operating system, to store the operating system, the complete operating system.
Okay.
Okay. Now let's see the boot order. So when we first power on the device, what it's going to do, this functionality, power on self-test, and it is stored in ROM. And if there is an issue, so what is the troubleshoot step? Contact vendor. Because if there is a hardware issue, we can't troubleshoot it or we can't rectify it. Okay. Now, in the second step, the device goes to NVRAM. And what it is asked from NVRAM, it asks NVRAM this value, configuration register value, which has iOS boot location.
Okay.
Means just like when we turn on our laptop or PC, what it does first, it test its hardware, that
Ah,
if keyboard is present and RAM is okay and everything is functionality
ah,
is fine. Then what it does, it try to find the boot location.
ah,
There could be multiple boot locations, a hard disk, or we can boot from CD-ROM, or we can boot from USB,
ah,
or there is a network boot option. Many options are here.
ah,
Okay, so that's how the network device does boot, that it goes to the NVRAM, and NVRAM
ah,
has this value, which value uh, guides the device that where is the operating system
ah.
boot. Okay,
Good.
where to boot the operating system.
Okay.
Okay, if this value got corrupt or the boot location provided is not right,
Ah,
means if for example in my laptop by default the boot location is hard drive, but
ah,
if somehow the hard drive got corrupt or hard drive got faulty,
ah,
then what's going to happen? There will be error, no boot device
yes.
found,
Ah,
because it is going to found look for boot in the hard disk, but hard
yes.
disk is
40.
faulty.
Yes.
So we will having a display an
Ah,
error which is no boot device found.
ah.
Similarly, if network device
Oh.
can't find the boot location,
Ah.
so we will having this display.
Oh, prompt.
If we connect that network device with a PC or laptop,
Ah.
then we will be seeing this greater than sign on the screen, nothing else.
Ah.
So if the greater than sign displays on the screen,
Ah.
we understand that the device is in a special mode which is called as ROM mon mode or ROM monitor mode.
Wrong terminal. Okay.
Okay, ROM
Okay.
monitor mode. And it means that in this mode, now you have to install the iOS again,
Ah.
or you have to change the iOS boot location.
Boot location. Okay.
Okay, you
Okay.
have to do something which is in your hand.
Ah.
You don't have to contact the vendor.
Okay. Okay.
As a network administrator or as a network device manager, you can do this on
Okay.
on your behalf, or if you contact the vendor, the
Ah.
person will come and do this for you.
Ah. Ah. Okay.
Okay,
Okay.
so this is not a hardware level fault.
Ah.
That's the point.
Okay. I
Okay,
got it.
but if we say that second step is successful
Ah.
and the boot location was good and device found the boot
Ah.
information right, but
Ah.
the operating system got corrupt in the boot location,
Ah.
and boot location can be a flash, a USB, and a TFTP server. Okay,
Okay.
TFTP is nothing complex.
Ah.
TFTP is a utility, a software we install on any system,
Ah.
and that system become a TFTP server.
Okay. Ah. Ah.
And what we does, that we put iOS image file
Ah.
on this PC.
Ah.
So what is going to happen in behind, that the device is going to contact that PC,
Ah.
which is right now working as a TFTP server, and it is going to ask that please provide me iOS image,
Okay.
and the iOS image is going to be loaded in the
Flash.
device.
Okay.
Okay, but if by default the flash is used for that.
Ah.
Okay, if the flash doesn't have a proper iOS and some iOS files are corrupt,
Ah.
so what is going to happen? This will this display is going to be on the
Oh.
screen.
Ah.
Okay,
Okay.
if this display is on the screen, it
Ah.
means that we are in RX boot mode.
Boot mode.
And what is RX boot mode? It is a mini iOS
Oh.
which loads from the NVRAM.
Ah.
Okay,
Okay.
so what happens, like Windows, Do you know that the blue screen error in
No.
Windows?
No.
Sometimes it happens that you turn on the PC and Windows load, and suddenly there comes the blue screen.
Yes.
Okay, so that blue screen error is very common.
Yes.
And so what happens behind that? The Windows is not uh, boot properly,
Ah.
and some files are corrupt.
Ah.
So it shows the blue screen.
Ah.
But there is an option. We can boot Windows in safe mode.
Okay.
There is a safe mode.
Ah.
Okay, have you done that?
No, sir.
No. Okay, let me show you.
Yeah.
Windows safe mode. Okay, every Windows has a safe mode. Windows 10, Windows 11, or Windows 12, every Windows. So what is a safe mode? This kind of mode. Okay, in which a minimum Windows is load with minimum capabilities.
Oh.
It is not a complete Windows, but what you can do, you
Ah.
can save your data
Ah.
by loading the Windows in safe mode.
Ah.
So this is kind of a safe mode.
Okay. Ah.
So what happens that
Ah.
in this mode, the difference between this
Ah.
ROM mode and RX boot mode is that in ROM mode, iOS never boots. So you
Ah.
can't do anything with device.
Okay. Ah.
But in RX boot mode,
Ah.
iOS loaded.
Ah.
So what is going to happen? Your device is going to work
Okay.
with limited capabilities.
Capability. Okay.
So what you have to, what you are, have you, what will you do? That you are going to take some downtime
Ah.
and again install the proper iOS or update.
Oh, okay.
Okay. So you
Okay.
can do this. So this is
Ah.
the troubleshoot option
Ah.
we have when we see this on the display.
Okay. Ah.
Okay. And
Okay.
again, and then if the iOS properly loaded, then there is configuration file which
Ah.
is saved, configuration file
Configuration.
in NVRAM. It
Ah.
is going to be load, and then finally everything is going to be loaded in the RAM.
Ah.
So what happens behind? Even in almost every device, this procedure is the same.
Ah.
So when we turn on the device,
Ah.
it is going to self-test.
Ah. Like
Then it is
every
every
layer.
device.
Okay, like switch,
Switch,
router.
router,
Ah.
firewall,
Okay.
every device has same steps.
Okay, sir.
Even your
What about bridge and hub?
bridge and hub are not, sorry, bridge can do this, but not the
Hub
hub,
no. Hub is the
because
system
hub is a
memory.
layer one device.
Layer one device, yes.
It doesn't have processor and memory, so it
Memory.
doesn't have these memories kind of thing.
Okay, from
Okay.
layer two device.
Yeah,
Yeah.
yeah. And when I'm saying every device, it means that my laptop, my PC,
Yeah.
my
Yeah.
mobile, every device has
Mm.
these same steps.
Booting. This is
First,
what happens behind the booting.
yeah,
Okay.
first power on self-test,
Ah.
self-test the hardware,
Yeah.
then find the boot location.
Boot location.
After finding the boot location, boot the device, load the iOS. And
iOS.
what I means load iOS?
Oh.
I
Load to
mean
the memory.
load in RAM.
RAM. Main. Yeah. For process.
Everything, yeah, means if I, why there is a limitation of RAM for Windows, means if you are going to install Windows 10,
Ah.
it asks that at least you have 4 GB of RAM.
Ah. Ah.
Okay, 4
Yes.
GB of RAM is minimum requirement to install
Ah.
Windows 10,
Ah.
because the Windows 10 operating system files are going to be loaded in the RAM during
Ah.
the boot.
Boot.
So
Okay.
the boot process where that circle uh, goes round and round, and we see that booting process. That booting process basically what doing in the what is it is doing in the behind. It is
Ah.
loading every important operating system file into the RAM.
RAM. From the
Okay,
primary
from the primary source, hard disk or
hard disk.
SSD or
From to the RAM
NVRAM.
for processing.
Exactly, exactly.
Okay.
Then the configuration files are loaded in the RAM.
Um,
And finally, everything
Configuration.
is in the RAM.
Oh,
Means
so.
when a device is completely boot,
Uh,
so we will be uh, what I should say, we will be accessing the device and what we are going to see what is happening in the RAM. But means we will be doing everything in the RAM right now in the
okay.
end.
Uh,
Everything this NVRAM and this flash are rarely used.
okay.
They are just used when the boot process is
Uh,
going to happen.
yes.
Okay,
Okay, sir.
this makes sense. These 5 steps.
Yes.
Now, hardware,
Yeah.
hardware. We are going to discuss more about hardware.
Uh,
Switches. There are multiple series of switches Cisco make, and similarly the other vendors make.
oh.
Okay, there are 3 type of switches:
Mm,
access layer switches, distribution layer, and core layer.
okay.
Okay, every vendor can name them according to their convenience.
Mm,
Okay, they are going to say them, uh, what should I say, standard switches, premium and pro switches, some like that.
okay.
Okay, or business layer switches, or home layer switches, something like that. Okay, they can rename. Cisco's name are these: access, distribution, and core.
Four.
So what is the difference between access, distribution, and core? It is the mm, users connectivity kind of thing. Okay, what
Okay.
happens that the access layer switches are for the in a network are going to use which switches are have directly connected users with them.
Uh,
Means if I have 50 users,
uh,
so what I am going to do, I am going to buy, for example, 4 16 port switches.
uh,
Okay, so each 16 port switch is connected with the users are connected with them.
uh,
For example, uh, 12 users per switch.
uh,
Okay,
okay.
I don't know I'm doing math right or not, but
Uh,
just like that. Okay, so
okay.
access layer switches are the switches which are connected to users directly.
Directly.
Okay,
Number
now,
of users is number of ports.
yeah, exactly, number of ports.
Okay.
Okay. So what is going to happen next? That for those 5 switches, I can use a distribution layer switches.
Uh,
That I use 2 distribution layer switches,
uh,
two for one switch for 2 and one for 3.
uh,
Then those 2 distribution layer switches are connected with a core layer switch, and this core layer switch then connected to router. We
okay.
are going to see this diagram
Yeah.
below. So
Uh,
let's not discuss in this in here.
uh,
Okay, that will going to make sense when there is a
yeah.
topology appears.
Okay.
So these are the models. The access layer switches are 9000 series, 1000 series, and there are Meraki cloud switches. And
Um,
the core and distribution layer switches are Catalyst series, Nexus series,
uh,
9000, 7000 series. There are data center switches are Nexus series for them.
uh,
Okay, there are industrial switches. Industrial switches means here is the difference. Okay, the
okay.
LAN switches or the access layer switches have more ports.
Uh,
Number of ports are 48 ports
uh,
or 32 ports, something like that. Okay,
okay.
this is
Okay.
the cloud managed switch, Meraki.
Okay.
Okay, so it can be used on distribution and core as well. Even
Oh.
it can be used on access layer as well. Means you
Uh,
can
uh,
do this, but the cost is different.
uh,
Then we have data center switches.
oh.
So data center have switches which needs thousands of ports, which may
Yes.
needs.
Uh,
So there is kind of this kind of rack, and there you have slots, so you
uh,
can just insert the whole ports card
uh,
in a slot.
oh.
Okay, and there are
Okay.
processing engines.
Uh,
So if you want to get the better performance, you can increase processing engines.
uh,
So you can scale, the scalability factor is here.
Yes.
Okay, so
Yes.
the scalability factor is here. You can scalable whenever you required. Means if you, for example, this, if you buy this rack and you fill it half, then the half is still available for you. So you can scale it whenever you need. Okay, there, and then there is service provider switches.
Okay.
Okay, so service provider also required the switches which have a lot of number of ports, because there are number of clients a service provider can have.
Ah.
Okay, so
Okay.
they have switches which are these kind of giant switches.
Ah.
Then there is virtual networking.
Okay.
The virtual networking is kind of thing which performed in cloud or in data centers. Okay,
Okay.
so they don't need many number of ports, because they are used for virtual networking.
Ah.
So a single number of port can virtually manage thousands or millions of users
Oh.
behind it. But obviously they are going to be connected somewhere physically.
Ah.
Okay.
Okay.
Then we have fixed switches. The number of ports are fixed.
Ah.
If the switch has 48 ports, you will get 48. You are not going to get any extra ports.
Ah.
Okay. Then we have modular switches like data center switches.
Oh. Ah.
Okay. We have slots. So we can insert the slots and
Ah.
we can get more ports
Ah.
whenever we
Okay.
need.
Ah.
And then there is stackable configuration. This
Stackable.
stack configuration is with these fixed switches.
Ah.
Some fixed switches are supported stacking function.
Okay.
What is this stacking function? That these switches have an extra port behind them, the stack port.
Okay.
And what we do, that we connect two switches or three or four switches with that stack port
Ah.
like this.
Okay.
So what is going to happen, that all these switches are going to function as a single switch.
Ah.
As I said, that we can't scale the fixed switches.
Ah.
So to scale the fixed switches, what we need is stacking.
Stack. Ah. Oh,
Okay.
connection. Ah. Ah.
So special cables are used to connect stackable switches that allow them to effectively operate as one large switch.
Ah. Okay.
Okay. So what is going to happen behind that? They all will operate as one large switch
One large switch.
rather than the different switches.
Ah.
So this is how stacking work.
Okay.
Then they are talking about the thickness. Usually the thickness is like for the one U rack, the racks have this kind of sizes, 1.7 inches thick and 444 mm in height.
Right.
Okay.
Okay.
So, and there are routers. Similarly, like the Cisco switches, we have three categories: access, distribution, core.
Ah.
Routers have three categories: small office, home office, SOHO routers, Robo, regional office, branch office, and CO, central office.
Okay.
So for a small office or a home, there is a different series of routers. For regional office or branch office, there is a different series of routers. And for the central office or head office,
Ah.
there is a different series of router. And like for cloud, there are different routers for data center, for service providers. So every requirement has different hardware availability.
Ah.
And not only Cisco does this, every vendor does this, like Huawei, Juniper, Alcatel, every networking service provider do this. They have multiple series of multiple categories to support multiple environments.
Okay.
Okay. So like for branch routers, they have 800 series, 900, 1000 series. For cloud, they have Catalyst 8000 series. For industrial routers, they have IR series and IE series. For service provider and core routers, they have NCS series and ASR series. and CSR series. So these are all
Okay.
the series for different vendors or different environments.
Ah,
Whenever someone needs to design a network,
ah,
then they needs to dig out or go deep in these series and
ah,
decide that which series router, and in even in that series which model
ah.
is going to work better in their
Okay.
environment.
Okay.
So before designing a network,
Ah,
you have to write down every aspect of the network, and you have to analyze that how this network is going to work, what capabilities this network should have, what
ah,
scalability you can expect. Means you are
ah,
starting from 100 users and
ah.
this can go to 1000 users or 2000 users, or no, it is not going to scalable like that, or this is going to be 200 or 300 users.
Okay.
Everything you have to keep in mind.
Fine.
Security is a concern.
Yeah.
For example, if this is an industry, then
Ah,
you have to be make sure that you are using industry grade devices.
ah.
Okay, so
Okay.
every aspect you are going to analyze, then you are going to decide that which series and which model you are going to use.
Ah,
And
yes.
obviously the cost.
Yes.
Okay, means you are not going to say that in an indoor environment you use
Ah,
industrial router. Why? Because they are more rugged.
ah,
And but if they are more rugged,
ah.
they are more costly. So
Yes.
if you use them in indoor environment,
Ah,
their ruggedness is not going to work.
yes.
That is useless. So why you are going to pay for that?
Yeah.
Okay,
Okay.
so these are the branch routers kind, and there is a difference between routers, the branch router, sorry, router and switch. That routers have limited number of ports always,
Okay. Ah,
because they are going to connect LAN or WAN,
ah.
multiple LANs and multiple WANs. They are not going to connect directly with the users.
Directly with yes. Yeah.
Okay,
Okay.
there are few routers
Ah.
which can have multiple functionalities. Means
Oh.
that device can work as a router
Ah.
as well as a switch at the same time.
Oh. Ah. Ah. Yes.
Okay, so
Ah.
that device can have multiple ports.
Ah. Ah.
For example, I can these are modular routers. All these
Mm.
images of a modular router.
Ah.
These are the locations where you can insert some cards.
Ah.
So I can insert a switching card here.
Okay.
Okay, so
Ah.
what I will get switching ports,
Okay.
and I can connect users to those switching ports, and then
Mm.
they are going to be routed from here.
Sir, is
So
it like the
yeah,
router we use in our home?
exactly. The router we use in our home is a three-in-one device. It is a
Yeah.
router, it is
Ah.
a switch, and it is
Ah.
a wireless access point,
Yeah. Ah.
because we get wireless access also.
Also, yes. And we can
Okay,
connect it as a switch, like we can connect, for example, if we have three PCs, then each with wire.
exactly. There are
Any type
usually
of a
four
switch.
ports
Ah,
in home routers.
okay.
Okay, so means it means that a single device can have multiple
Purpose.
functionalities.
Yeah. Mm.
Okay.
Okay.
Similarly, about switches, there
Ah,
are two types of switches, layer 2 and layer 3.
ah,
So
oh,
few are layer 2 switches, you can just connect users and perform layer 2 functionality. They can't
ah,
perform routing. But
routing.
there are
Ah,
layer 3 switches.
oh,
So they have functionality of layer 3. So you can
mm.
perform layer 3 functionality on those switches as well
Which mean as a router.
as a router. But
Okay.
usually in enterprises, the
Ah,
switches works for the switching per,
ah,
as aspects, and router works for routing
routing.
purpose.
Ah, okay.
Okay.
Oh,
This is network edge routers. Network edge routers means
ah,
uh, service provider routers.
ah, yes.
Okay.
Okay.
They
Okay.
can be in the data centers, or they can be somewhere in the head office kind of thing,
Where many
where
networks are connected together.
exactly multiple branches are
Okay.
connected.
Ah,
There is coming data from multiple branches or multiple
ah,
sources.
For example, different branches of a bank, is it like that, sir?
Yeah, exactly. Different branches of a bank are connected with the head office. So head office can have these type of routers.
Okay, sir. Yeah.
Then there are service provider routers. This
Oh,
is NCS series.
oh,
Then these are industrial routers. So
industry.
they look like the industrial routers, the rigid routers kind of routers,
Oh,
which
oh,
can perform in every kind of temperature, high
oh,
temperatures, low temperatures,
oh,
or they are IP67 kind of standards
uh-huh.
applied on them. So they can be
Okay.
waterproof or something
Ah,
like that, heat proof, waterproof. So means they are rugged in
ah,
harsh environments.
harsh environments. Okay. Maybe using outside.
Outside, exactly, for outdoor purposes, where you need to connect them outdoor. Then
Mm.
this is the 900 series. So
Okay.
this is a small home router. So
Ah,
it has WAN, it
ah,
has LAN.
land. Yeah.
Okay.
Okay.
Again, there are big
WAN
routers.
means the internet connection, right?
WAN, yeah. No,
Mm.
not internet. WAN,
That
WAN means
WAN.
service provider.
Service provider. That
That
line
service,
that connects from the.
yeah, exactly. WAN is service provider. It
Mm.
is internet in nowadays, or
Ah,
we understand internet, but there is without internet connection as well. Means there is a simple connection which is not internet, but it is a
ah.
WAN connection.
Oh.
And usually the banks use them because banks
Okay.
need to securely send the data from head office to branches. So the branches to head office connection is not the internet kind of connection. It is
Oh,
a simple
WAN.
WAN connection.
Ah, with
So when,
wires.
yeah, with wires, and the service provider can do that because service provider
Ah,
has its infrastructure laid out in the country or in the city.
ah.
So
Oh.
what service provider do?
Ah,
It asks you that give me some money and
ah,
I will give you my infrastructure.
ah. Okay.
Okay.
So that they are interconnected without the internet, which is not safe.
Yeah, exactly.
Ah,
Because internet is not 100% safe.
ah.
Okay.
Okay.
Now we have this is 5500 series routers and industrial routers, Falana Dimkana. This is the topology I was talking about.
Ah.
So Cisco say that there are, if you are designing a LAN
Hmm.
from scratch, you
Ah.
can have two type of concepts in your mind.
Okay.
One is two-tier architecture,
Ah.
the two-tier architecture for small networks, kind of networks.
Okay.
Like there are access layer switches,
Okay.
which are from which users are directly connected.
Directly connected. Yes.
Then there is a distribution layer switch,
Oh.
and this distribution layer switch is also functioning as core layer switch and connected to the router.
Okay.
Means there is no core layer here.
Mm.
This is
Which
two-tier architecture. Access layer,
Okay.
distribution layer.
Okay. Core layer is not there.
Core layer is not here.
Ah. Okay.
Okay. This
Okay.
is a this is for a small network.
Okay.
Okay. But if you have a large network and you want scalability and
Hmm.
redundancy,
Ah.
what is redundancy? Redundancy is
Data.
backup links
Back. Uh-huh.
or backup devices. It is called redundancy.
Uh-huh.
And you want load balancing,
Okay.
then you can design the network like this, the three-tier architecture.
Okay.
The access layer, the
Ah.
distribution layer, and the core layer.
Core layer. Yeah.
Okay, so what is
Okay.
going to happen that every access layer switch is connected with both the distribution layer switches. So if our distribution layer switch goes down,
Ah.
network is still going to work.
Okay.
If this connectivity goes down, there
Ah.
is a backup link.
Backup layer. Ah.
Okay. Similarly, both the distribution layer switches have two links connected with each other.
Ah.
Okay.
Okay.
And similarly, this distribution layer switch is connected with this core layer switch and this core layer switch as well.
Oh.
So there
Okay.
is not any single point of failure in this diagram. Means if you want your network to be consistent and you want a network which is highly available. So how can it be highly available if every device has a backup device
Yeah.
and
Okay.
every connectivity has a backup connectivity?
Uh,
And similarly the routers.
yeah.
So there
Okay.
are two routers and each distribution is, sorry, core layer. So it is connected with both the routers.
Both
So
the
if a
router.
router goes down,
Uh,
the internet or the network is going to work with second
one
router.
router. Okay.
Okay. So
Okay.
this is three-layer architecture.
Yes. Okay.
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 Now this one is going to be a separate topic, the lecture 5. We are going to continue it tomorrow and it is very important.
Okay,
Okay.
sir.
I hope, are you available tomorrow? Tomorrow is Saturday.
Saturday, yes, sir. Because Saturday and Sunday no class, or is there you have time, sir?
I have time. I can continue classes on Saturday or Sunday in just if any family event or something like that occur, I will inform you. Otherwise, I am available on Saturday and Sunday as well.
Okay, so it is according to you, sir. I am always available. You can text me any time.
And there is one more thing I want to discuss. Can
Yes.
we change the time